just want the distance from, you are looking at the vertical height or the difference in height between two places. That is simply what gradient is all about. So assuming you are given a place here and then a place here on the topographical map, and then they ask to calculate the gradient between these two places. All they are asking is that what's the difference in height between here and here, or as when we move from here to here, what difference of height will we experience? That is basically what gradient is all about. So now let's look at the steps in calculating for gradients. Come here, then the steps are very simple, just six practical simple steps. The first one, as always, when you're given something in geography, you have to identify what you've been given. And here, because its gradient is between 2 points, you identify our 2 points, and then you draw a line to connect the 2 points. After that, you determine the horizontal equivalent, where this horizontal equivalent is this point A to point B. What's the total distance? You use your ruler to measure to get the marked distance, and then you convert based on the scale to the actual distance. And then also find the vertical increase by finding the equation of the 2 points. That is, you find the height of point A and then point B, and then you subtract the smaller one from the bigger one. So, and then you express both the horizontal equivalent and the vertical increase in the same unit. Normally, the vertical increase, given our topographical maps, the vertical increase will be in feet, and then the horizontal equivalent will be in meters or centimeters. So you have to convert them to the same unit. Either convert the inches or feet to meters, or you convert the meters to feet. Depends on you. And then calculate. After that, you calculate for your gradients, and you are done. Simple as that. Over divided by horizontal equivalent. So begin, we first can find the vertical interval and the horizontal equivalent first. What matters is that we find both of them. But let's follow the steps. So step 1 on the map, we come to our map. Step 1 says we should identify the 2 points. So if we identify point A on contour 250 feet, and then point B on contour 100 feet. So let's draw our line to connect the two. Connected. And then the next step is to determine the horizontal equivalent. So that is determine the distance between them. So we place our ruler here. You can measure in inches, you can measure in centimeters. I prefer centimeters. So you can see it's on 11.8. Yes, so that is 11.8 centimeters. That's the horizontal equivalent on. That is the horizontal equivalent on the map. So HE is equals to 11.8 centimeters. You have to then bring it to the ground distance. Now based on the scale, and the scale is 1 is to 50,000. So here we divide, and then 11.8 times 1 divided by 1 is 50,000 becomes 11.8 times 50,000 over 1, which gives us 590,000 centimeters. So this centimeter then we convert to meters or kilometers. Let's convert to kilometers. So divided by 100,000, because 100,000 centimeters gives us 1 kilometer. So 0, 4 zeros, 4 zeros. It's left with 10. Then we see it comes to 5.9 kilometers. So this is our horizontal equivalent. That is the distance from point A to point B on the ground. So we insert it in our scale 5.9. Now to find our vertical interval. So let's go back to our map. And on the map it says to find the vertical interval from the board. From the board here. It says to find the vertical interval, you have to find the elevation of the 2 points. So let's see the elevation of point A and point B. So point A has an elevation of 250 feet, and then point B has an elevation of 100 feet as it is written on the contour line. In case it is not written, you have to find the contour value by finding the contour interval. So you have to find the contour value. Okay, so this is that. So 100 and then 250. So what we do is that we subtract this from this. So on the board we have so this is our vertical interval. Let's place it in our formula. So we have 150 feet divided by 5.9 kilometers. Vertical interval, we have our horizontal equivalent. But as you can see, they are both in different units. This is in feet, this is in kilometers. The 0.5 says what? You have to express them in the same units. Even if it doesn't say you have to express them in the same units, we still have to express them in the same unit because we can't divide feet with kilometers, or you can't divide feet by kilometers and that. So you have to get them to be in the same unit. Either they'll both be in feet or they'll both be in kilometers. And well, I am more conversant to the kilometer, so I will prefer I change this feet to kilometer. So let's convert the 150 feet to kilometers. So first, to convert, you have to convert it to meters and then convert the meters to kilometers. And we know that 1 feet is equals to 3.28 meters. Okay, so if 1 feet is equal to 3.28 meters, how many meters will 150 feet give us? 1 feet, so you do a cross multiplication. 1 times x is x equals to 150 times 3.298. On our calculator gives us 492. So that means that 150 feet is equals to 492 meters. Now we have it in meters. We convert the meters to kilometers. And we know that 100 meters gives us 1 kilometer. So we just divide to 1, 2, which gives us 4.92 kilometers. Okay, so this is it. 4.92 over 5. Kilometers. Now we have both VI and then HE in the same units. The next thing to do is to calculate the gradient. And with the gradient, always the numerator becomes 1. So what we are going to do is we are going to divide both sides by the numerator. So 4.9 goes into 4.92 goes into 4.921. Then 4.92 goes into 5.9. Now you calculate on your calculator as 5.9 divided by 4.92, which gives us 1.199 or 1.2. So that means that 1 over 1.2. This is the gradient. But you don't leave it as is. Normally, you are supposed to write it in a statement form. And that statement form, this we can state it as 1 in 1.2. That means that for every movement of 1, there is a vertical rise of what? 1.2. That's when you move 1, whether 1, since there's no unit, it can be whether 1 kilometer, 1 inch, 1 centimeter, 1 whatever. When you move 1 of that unit, there will be a vertical rise of 1.2 of the same unit. So this is how you write it in statement form. So all these calculations, you are supposed to work in your book systematically. We are going over. On the map, you identify your 2 points. You draw a line to connect the 2 points. And then you find your horizontal equivalence by just calculating the map distance between the 2 places, and then you convert, see the map distance between the 2 places, and then you convert towards the ground scale, which we had as this. And then it's in centimeters or whatever. It depends on your scale. Then you convert that scale to kilometers. If already you want to convert to ground distance, it is in kilometers, there's no need to do this. Ours was not in kilometers, so we had to what? Convert to kilometers, which we had 5.9 kilometers. Then we found, or we calculated for our vertical increase, which was the height of point A minus the height of point B. Here point A was higher than point B, so we just subtracted the vertical interval. We subtracted point B's height from point A's height, and then we had the vertical interval. Then we came to divide by the horizontal equivalent, but then since they were both in different units, we had to convert one of them to the other. So we converted the 150 feet to 5.9 kilometers, where we were converted 150 feet to kilometers, where we had 4.9, because 1 feet is equals to 3.2 meters. So you just do your cross multiplication that 150 feet is equals to x meters. So just cross multiply as we did when we had 4.92 kilometers. Here we first converted to meters, and then we had 492 meters, and then we converted that meters to kilometers, which was 100, and giving us this. Then we just found our gradient, where the gradient we calculated as this always has to be 1. So what we did was we divided the numerator and then the denominator by this, where this goes into this of 1 is here, and then this goes into this, how many? It was 1.2, which we had here. It was actually 1.199 and then plenty others, but I just wanted to the nearest 1 decimal place. We had 1.2, and then we wrote it in statement form. After writing it this way, please try to write it in statement form, which is 1 in 1.2. The explanation being a movement of 1 will lead to a vertical rise of what? 1.2. As simple as that. Thank you. We are looking at bearing. And bearing, as all the other things we've done goes, you have to identify your 2 points. So if you identify the 2 points, points A and B. So the next step you do is that you draw vertical and horizontal lines on those points. So this is the point, so we draw a vertical line. Make sure it is straight as can be. No slanted line or anything. Draw a straight line, just a cross. Draw a cross, but make sure the lines are straight. So one straight line here, and then another straight line here. Then you come and do the same thing for B. So one straight line here in the middle. Make sure they meet exactly on the point. So you see it's another straight line. So the next step is to draw a line from A to join B. So we draw a line to join B. Now so we've connected the two of them. After that, depending on the question, if you are asked to find the bearing of B from A, that means if one is at A what is the direction, or what is the number of turns the person have to make in degrees to face B. So what we do is you get your protractor, you place, always remember the 0 is the north, so this is 0, then 90, 180 and so on. Okay, so 0 as well as 360. So this is 0, you make sure the 0 on the protractor is on the 0, so you place it on it nicely. Very good. So it's a nice line exactly on it, on the cross. So you see the ups and downs is on the cross. This is also here. So now we read from 0, 30, 40, 50, 80, 90, 100, 180, 130. Then we can see from the line that we can see it's almost about 135. Yeah, let's say 135. So that's the bearing from A to B is what? 135 degrees, and then you are done. As simple as that. In case you are asked to find the back bearing, see now you find the bearing of A to B, or the bearing of B from A. Now if you are asked to find the back bearing, that will be from B to A, and that one is very simple. You just, instead of measuring from here, you come and measure from here. But here we can see that when we place the 0 here, it is impossible to calculate up to this side. So what we do is that we note in our mind that this side, this is 0, this is 180. So we come to start from here. So we've already traversed 180 degrees. So let's put that 180 down, and then we start here at 0, and then we move 0, 0, 10, 20, 30, 80, 90, 120. So we can see it is what, 132. Let's say 132. So what we do is that we add that 132 to the 180 we already have here, giving us 213. That means the back bearing is what? 312 degrees. As simple as that.